Hey everyone, hope you're doing great. I am a software engineer at a FAANG company, and today we are diving into something that every aspiring software engineer, TSA learner, or tech interviewee really struggles with at some point. How do you study lead code efficiently without burning out or getting lost in 3700 problems? Whether you are prepping for your first interview or trying to level up, the biggest challenge is knowing what to solve, when, and how. So, in this video, I will show you how to crack lead code by mastering just 12 core patterns instead of solving problems blindly. Quick note, everything I share here is based on my personal experience and is not affiliated with the company that I work for. So let's get into it. So here's the issue. LeetCode has over 3700 questions and that number keeps growing every week. There are weekly contests, company tagged questions, and discussion forums telling you to solve 500 problems to get good. But who has the time for that? Most people try the brute force method, which is just solve one question a day and you will get better. Sounds good in theory, right? But here's the math. One problem a day translates to 365 questions in a year. And at that rate, it's gonna take you 10 years to solve everything. And that's assuming you don't take a single break. Now add in school, add in work, family, life. It's just not realistic. So, what's the smart approach? What's the solution here? Don't try to solve everything. Learn to recognize patterns. The key is to master the 12 core patterns that keep showing up across hundreds of questions. Once you understand these, you can decode and solve most new problems just by recognizing the underlying pattern. So, I'm going to start showing you the 12 must know lead code patterns, and here they are. The first one is called sliding window. It's used for problems with substrings, subarrays, or fixed window sizes. The common type of problems are longest substring without repeating characters. As you can see from the title itself, it has substring. And another one could be minimum size subarray sum. So as you can see, it has the word subarray in it, giving you enough hints that it falls under substring subarrays, and hence one can try the sliding window pattern. The second one is called two pointers. It's ideal for sorted arrays, removing duplicates or searching pairs. Some examples are removing duplicates from sorted array. This one directly tells you anything to do with duplicates, arrays, and hence it falls under two pointers. Two sum two input array is sorted. Again, another question with sorted arrays. These are really good hints that you can derive from the problem itself, that it has to do with arrays, sorted, duplicates, and hence the two pointers approach. The third pattern is called fast and slow pointers. It's typically used in linked lists, especially to detect cycles or finding midpoints. Typically here a fast pointer would move really fast while another one would be approaching from behind slowly, and then both pointers would meet at a point where a cycle would be detected or a midpoint would need to be found. So it is used for problems like linked list cycles. That's one example. The second one would be linked list cycle 2. The fourth pattern is called hashing. It's great for frequency counting, quick lookups, and avoiding nested loops. Examples would be two sum and group anagrams. The fifth pattern would be binary search. It's not just used for arrays, but it's also used in search optimizations and problem involving k smallest. Examples would be finding minimum in rotated sorted arrays. searching in a 2D matrix. The sixth pattern is called DFS and BFS. DFS stands for depth for search and BFS stands for breadth for search. It's used for problems where there are trees, graphs, traversal based problems including shortest path. Examples would be maximum depth of a binary tree, number of islands. The seventh pattern is called backtracking. It's used for permutations, combinations, and exploring decision trees. Example would be permutations and combinations. The eighth pattern is called dynamic programming. It's used for problems with overlapping subproblems and optimal substructure. Examples would be climbing stairs and house robber. The ninth pattern is stack. It's used for parsing, expression evaluation, and monotonic stack problems. Examples would be valid parenthesis and main stack. The 10th pattern is called greedy pattern. It's used for solving problems with local optimal choices that leads to global optimum. Examples would be jump, game, and merge intervals. The 11th pattern is union find, also called as disjoint set. It's used for graph problems involving connected components or cycle detection. Examples would be number of provinces and redundant connection. And the 12th and the last pattern is topological sort. It's used for task scheduling and resolving dependencies in graphs. Examples would be core schedule and alien dictionary. So here should be your study plan. Now that you know the 12 patterns, the best way to build your LeetCode strategy smartly is by doing this. First, you need to pick one pattern in a week and stick to it. Solve 3 to 5 problems per pattern. Start with the easy ones, then go to the medium ones, and optionally try some hard ones. Focus on the approach, not just code. Really understand why a pattern works before moving on. And revisit these patterns every few weeks. This reinforces memory and boosts pattern recognition. With this approach, instead of solving 1,000 questions randomly, you should be able to solve 50 to 60 high quality questions with clarity, and that's really enough for 90% of your interviews. That's it for today, folks. If this video helped clarify your LeetCode journey, make sure to like this video, drop a comment, tell me what are your favorite patterns and problems, and subscribe so that you don't miss more videos like this. Study smart, not hard, and I will see you in the next one. Happy coding!